these are the rest of the lesson 3.2 notes, and we are focusing on elimination. So in the first section first video, we looked at the first two ways of solving, which are graphing and substitution. And the third way of solving is elimination. Again, you can use any of these forms to solve. Depending on the equations that you have, that will determine which method is the easiest or the fastest. So again, the last way of solving is elimination. Just a reminder that your solutions for systems of equations are always where your lines are intersecting, and that is your solution. So for example 3, we are solving using elimination. So the key with elimination is to eliminate one of the variables so that you can solve for the other variable. So we want to look at our equations vertically. So we have a negative x and a 4x. We have a 3y and a 6y. So we want to make these so that they will be eliminated or equal 0. So if we look at negative x and 4x, we notice that they are opposites. So if we multiply our first or top equation by 4, as long as we multiply everything by 4, it will be the same equation, it'll just be written differently. So negative x times 4 is negative 4x, 4 times 3y is 12y, and 4 times 1 is 4. And then we're just going to rewrite our second equation, 4x plus 6y equals 8. And then we're just going to add the equations. A negative 4x and a positive 4, which we know is 0, so that's gone. 12y plus 6y is 18y. And 4 plus 8 is 12. We solve for y. We divide by 18. So y equals 12/18, which we know that we can divide by 6, and that will give us 2/3. Now to solve for our second variable, we need to plug into our second equation. So we have 4x plus 6. Again, our y value is 2/3, so we're plugging that in for y, and that equals 8. So we have 4x plus, remember this is 6 over 1, so 6 times 2 is 12, 1 times 3 is 3, 12 divided by 3 we know is 4. Then we're going to subtract 4 from both sides. 4x equals 4, divide by 4, and x equals 1. So our solution again is a coordinate, so our x value comes first. So this is 1, 2/3. And again, this is the point where these two lines will intersect on a graph. Now notice that our solution has a fraction in it. If we were to graph these two equations, we wouldn't be able to find the exact point where they intersect. We could round, we could estimate, but we couldn't find that exact 2/3 for our y value. So again, sometimes elimination or substitution will work better than graphing, just depending on what your equations are. Example 4, you're solving using any algebraic method. So there's a couple different ways that we can solve these systems of equations. There's no one right answer. There's a lot of different ways that you could use. Again, any method would work. It just depends on which one you would like to use and which one is going to be the easiest. So if we notice here, our first equation, we have 4x equals 3y. So we can easily move both our x's and y's to one side and use elimination. You could also solve for either x or y, but notice then you'll be dealing with fractions. So we want to stay away from fractions. So let's move our 3y to the left, and then we'll solve using elimination. So if we subtract 3y, we get 4x minus 3y. There's nothing left on the right hand side, so it equals 0. We still have negative 10x plus 7y equals negative 2. So now we need to eliminate one of our variables. So I want you to think about what can we multiply 4 and 10 by so that they will be eliminated, or what can we multiply 3 and 7 by so that they will be eliminated. I'm going to multiply my first or top equation by 5, and my second equation by 2. You will notice that in doing this, 5 times 4x is 20x, negative 3y times 5 is negative 15y, and 0 times 5 is 0. For the second equation, we have 2 times negative 10, which is negative 20x. 7 times 2 is 14y, and that equals negative 4. So notice that each of my x's, one's 20 and one's negative 20, so those cancel out. Negative 15y plus 14y is negative y, and that equals negative 4. So again, we're going to divide or multiply by negative 1, so that gives us y equals a positive 4. So again, from here, we're going to go back to our equations, plug in our y value to get our x value. Again, it doesn't matter which equation you use, whatever one is the easiest. Notice that the top one is easier because we have less numbers to work with. So we have 4x equals 3 times 4. So 4x equals 12. Divide by 4, so x equals 3. So our final solution is 3, 4. And again, any of the methods, graphing, substitution, or elimination would work. It just depends on your equations, what is going to be fastest, what is going to be easiest. If we look at example 5, again, we're using any method. So notice our first equation, we have y equals 3x plus 5. Notice we have y all by itself here. So we can use substitution. So we're just going to substitute 3x plus 5 in for the value of y for our second equation. So we have negative 9x minus 3 times 3x plus 5, and that is equal to 15. Again, we need to get rid of our parentheses, so we're going to distribute. So we have negative 9x minus 9x minus 15 equals 15. Negative 9x minus 9x is negative 18x. We still have minus 15 equals 15. We add 15 to both sides. We get negative 18x equals 30. Divide by 18, x equals 30 over negative 18, or negative 30 eighteenths, which we can simplify to negative 5 thirds. Can divide by 6. So again, our x value is negative 5 thirds. Then we're going to plug that back in to solve for our y value. Now we can plug it back into our first equation. That's going to be the easiest one to plug into. So we have y equals 3 times negative 5 thirds plus 5. Now notice the 3's are going to cancel out, and we just have negative 5 plus 5, which we know is equal to 0. So our y value is 0. So our solution then, our x value is negative 5 thirds. Our y value is 0. So our solution, or where the lines intersect, is negative 5 thirds 0. Our last example says the sum of two numbers is 14. Their difference is 24. Find the two numbers. So first you're going to write a system of equations for the situation. So we don't know what these two numbers are that we are finding the sum and difference to. So we're going to call them x and y. So the sum of the two numbers is 14. Remember, sum means addition. So if we add these two numbers together, we know that it's going to be equal to 14. The second part says the difference. We know that that means subtraction. So we know if we subtract these two numbers, it's 24. So x minus y equals 24. So this is our system of equations. So now we're going to solve the system and answer the question. Notice that we have a positive y and a negative y. So the easiest, fastest way is going to be using elimination. So we have x plus y equals 14. X minus y equals 24. Our y's cancel out. So we have 2x equals 38. Divide by 2. And x equals 19. So then we're going to plug that into either equation to get our x value. So if I plug that into the first equation, we have 19 plus y equals 14. We subtract 19 from both sides. Y equals negative 5. So our two numbers are 19 and negative 5. Now if we plug these into the original problem, it should work for each equation. The last example says, without solving, which method would you use? How many solutions will you have? So we have two different systems here. I want you to figure out which method you would use, which would make the most sense. And I want you to look for patterns and see how many solutions you think that these systems of equations will have. So again, I'm not going to go through the answers right now. We're going to go through those in class tomorrow. But again, I want you to figure out which method are you going to use, which method makes the most sense. And without solving, how many solutions are you going to have? Again, look for patterns that you see. Think about what the solutions mean as far as one solution, many solutions, and no solutions, and see what you can determine from those.